In this video, we're going to learn how we can create a Kubernetes cluster from the scratch using kubeadm. Now, this setup is very important, especially for those who are preparing for their CKA, and whatever concept you're going to get from here applies on your exam as well. This is how the flow of execution is going to look like. So firstly, we need servers to provision the cluster. Now we need compute, and we're going to be using AWS cloud or AWS platform to provision those servers and virtual machines like EC2 instance. So we're going to be using EC2 instance. So the first thing we're going to be doing is, number one, we're going to create a VPC, and because your cluster needs to be on a network whereby all the nodes can communicate with each other. Because of that, we need VPCs, one VPC to be provisioned. So secondly, we're going to create security groups, and for the master node and the control plane, we're going to create two separate security groups. Then after that, we're going to provision three EC2 instances. Sorry, it should be three, not two. Not four. So we're going to be provisioning three EC2 instances, one for the master node and two for the worker node. Then after that, we are going to connect to each machine and install the Kubernetes component on each and every one of them. Then after that, we're also going to connect to the master node to initialize the cluster. We'll do the same for the worker node and then add them to the cluster. Then also, we are going to be installing a CNI plugin. Right? As we all know, without a CNI plugin, your pods will not be in a running state. Your pods are not going to communicate with each other. So we need to install one implementation. And the one we're going to be using in this video is Cilium. So we're going to be installing Cilium. Then lastly, to make sure that the Kubernetes has been, to ensure that our cluster has been set up properly, we're going to be deploying a simple application. So this is how it's going to look like. So provision the EC2 instance, and then we're going to be installing kubeadm into each and every one of the server. Then after that, we're also going to install kubelet. Now, all these are the components that we need to install on each of the worker node. So we're going to be installing kubelet as well. Like I said in my previous video, kubelet is the agent that runs on each of the node to report the status of the pod and the node itself back to the Kube API server. So after that, we need to install a container runtime on each and every one of the servers. So we're going to be using containerd as our container runtime, and we're going to be installing it on each of the servers. Then after that, the plugin we're going to be installed, like I said earlier, is going to be Cilium. So we're going to be installing Cilium as well. So just a recap, we need to install the component on each of the node. Now, the components that we need to install on all of the nodes are the kubeadm, the kubelet, and the container runtime, as you can see on the screen. Then after that, after the whole cluster has been bootstrapped, we've joined the worker nodes to the control plane. Then we can now install Cilium, which is the CNI plugin that we are going to be using in this demo. Now, this is my AWS console. I'm going to head over to my VPC session to create the VPC. So I'm going to click on VPC. Then go to my VPC and create a VPC. Then I'm going to give it a name. Now, if you are creating a VPC, there are so many ways you can actually do this. You can use Terraform, but in this video, I want to do everything manually so you can understand how everything works. So I'm going to go with VPC and more. And first of all, we're going to give the VPC a name. I'm going to call it Kubernetes Cluster. I'm going to give it that name. And also, I'm going to choose a CIDR block. Now, the CIDR block is the IP range for your network, right? So I'm going to be going with, I'm just going to use 10.1.0.0/16. You can choose any CIDR block that you want to use in this case, but just be very careful because the CIDR block that you're going to be choosing as your network CIDR block must not conflict with your pod network in the cluster. Just take note of that. Then after that, I'm going to scroll down. I'm going to leave everything as it is. And number of availability zone. Now, in this video, I'm just going to go with 2 availability zones, and also number of public subnet. I'm going to leave it as 2. The number of private subnet, I'm going to leave it as 2 as well to make it 4 total subnet. Then also in the NAT gateway, obviously, since our cluster, some of the components are going to be provisioned in a private subnet, we need a NAT gateway. So I'm just going to click on zonal NAT gateway, and I just need one, right? I just need one in one AZ. I just need one NAT gateway in one of the AZs. Mind you, NAT gateway are very, very expensive. So make sure that after this demo, you delete it as quickly as possible. Then we don't need VPC endpoint. Click on none. I think that's all we need. And I'm going to click on create VPC. Now, while our VPC is creating, let's head over to the EC2 console to provision those to create our security group. Now I'm going to head over to the other side, and I'm going to go to the security group. So scroll down to security group. Now, before we create the security group, we need to understand which ports, right? Which ports that we need to open on each of the security group. Because the security group that we want to create is for the control plane and also for the worker nodes. Now we need to specify which ports that need to be open. Now, how do we do that? Now let's head over to the Kubernetes documentation, right? I'm going to leave the link on the comment section, right? So I'm going to leave it. I'm going to leave the link below. Now, if you come here, you're going to see the documentation, and this is where all the steps for installing and using kubeadm to bootstrap your cluster, all of them are here. So if you scroll down, you will see some prerequisite, right, before you begin. Now, if you read through it, you're going to see that we need Linux machine. For that, we also need to make sure that each machine have at least 2 GB of RAM, and also 2 CPU cores, 2 CPUs, and full network connectivity between all the machines in the cluster. And this is the major reason why I created a VPC, so that all the machines, all our nodes should be on one VPC so that they can communicate using the private network. And also, you can see there are 30 ports, some 30 ports are open on your machine. So you need to make sure that some 30 ports are open. Now, what are those ports that needs to be open? Now, if you click here, you're going to see the required port. So if you click there, it's going to bring you here, and also click on the required port. Now, if you click on the required port, you're going to see all the ports that needs to be open, right? So for instance, for the control plane, we need all these ports to be open for the control plane. Now, these are the ports that we need to specify on our security group. Now, let's go back to the security group. So let's click on create security group. And for this one, let's call it the control plane SG. My bad. Control plane SG. And the description is going to call it, let's give it the same name. Paste the same name here. And also on which VPC. Now, click on here and make sure you select the VPC, right? Make sure you are selecting the VPC that we created. So let's add the inbound rules. Now remember that these inbound rules are the ports that we want to be open on the server. So if you don't specify this port, by default, nobody can access your servers or your instances. So let's click on add rule. And the first one we're going to add is this one, which is the 6443. Now this is the port that the API server will be listening on. So we need to open this port, right? So let's come here and click and put the port. And the IP source is going to be from anywhere, because if you come to the documentation, you can see that, it's used by all, meaning we need to make it public, right? So let's leave it like that. And we can just say allow access to API server, right? Then click on add rule, add another rule, come here again and look for this port. Now this is the port that HCD is listening on. So let's go back, add it here, and now we need to specify which IP CIDR block can access the HCD. Now we're not going to make this public because HCD is very sensitive. So what are we going to do? we are going to alert all traffic within the network. Now, if we come here to our VPC, right, this is the VPC we created, click on it. Now, we're going to be allowing all traffic from this VPC, which means that it's only going to allow internal communication from this CIDR block. Now, let's go back and specify that as the CIDR block, right? So we can say allow connection from within VPC. So click on add rule again, go back again, and for kubelet, we also need to do the same. Go back and for kubelet, paste the port, and we're also going to leave it at 10 points. We're going to leave for 10.10.1.0.0/16. So we also need kubelet to communicate internally, right? So, and the last one, which is 10.259, this is where the kube scheduler is listing on. Now, if you notice very well, this kube scheduler, the only people that need access to it is the server itself. You can see self, so you need to communicate with itself. So we don't actually need to specify any rule for these two, because no external body needs to communicate with it. So there's no need for us to add rule. So the communication with this is going to be within the server itself, which is a local network, right? So let's just leave it like that. So these are the only 3 rules that we need. Let's delete that and let's create rule, create security group. Now, why this has been created, we also need to add one more rule, right? We need to connect to the machine. We need to SSH into the machine to install those components. Now, we're going to be connecting using port 22, and I'm going to leave it on from my IP. So you can see from my IP, I'm going to leave it like that. Click on my IP, because obviously I want to connect myself. I don't want anybody to access it. So I'm going to click on save rules. Now, once that is done, we need to create another security group again for the worker nodes. Now, let's go back again to security group, create another one. Now, this is for the worker security group. So I'm going to, worker SG, and also do the same thing here, worker security group. And the VPC, I'm going to select the one I created, which is that one. And also, we're going to add rule for the inbound rule. Now, let's go back again, scroll down to the worker nodes. Now, for the worker nodes, we need port 1250 to be open, and this needs to be communicated. This needs to communicate with the control plane and itself. So, specify the port here, and also specify the CIDR block of the VPC, which is 10.1.0.0/16. For that, click on add rule again, find the second one. This is for the kube-proxy. Now, since we are using Cilium, as our CNI, we are not going to need kube-proxy, right? So we can as well do away with this particular one. I will explain later when I get to that part. Now, the only thing that we need to now open is this port 3000. Now, this port is needed for, for creating node ports, right? We might not need it in this demo, but let's just add it just in case we just want to expose our application. So now this is it. It's open, and then we need it for TCP, and we need it for everyone, or IP, right? Because if you come here, you will see that everybody needs to access it. So it's for everyone. So that's it. And also, we also need the same for UDP, right? It's the same rule, but this one is going to be for UDP and also for everyone as well, right? So that's all we need. And also, we also need to connect to the machine, right? We need to connect to the server as well. So we need to add that rule for port 22, and it's going to be coming from my IP. Then click on create security group. Good. So we've successfully created the security group. The next thing that we need to do is to now create the servers, the virtual machines, right? Now let's go back to instance and launch instance. Now the first one is going to be the master, right? The master node. Let's just call it master. And also, we're going to be using Ubuntu as the operating system, right? We need Linux machine, so we're going to be using Ubuntu. Scroll down and, we're going to leave it free tier eligible. And also, now for the instance type, if you come here to the documentation, now this documentation is going to be your guide, right? Like I said, I'm going to leave the link in the description, in the video description. Now, if you scroll down, you're going to see that for the master node, right, for the control plane, we need at least 2 CPU, right, for the control plane machine. And also, we also need 2 GB or more of RAM. So we need at least 2 CPUs and at least 2 GB of RAM. So let's come back. Now, if you look at this T3 micro, we have 2 CPU, but it doesn't have at least 2 GB of RAM, right? So this T3 micro is not going to work, right? So let's look for a suitable one. I think T2 medium should be a perfect one for us because it has at least 2 CPU and it has more than 2 GB of RAM. So let's go with T2 medium. Now, let's select T2 medium. But mind you, be very careful. As soon as you are done with this demo or this tutorial, please ensure to delete it. Make sure you are cleaning your resources. Otherwise, you're going to get charged. So that's that. So after that, we selected the instance type. Then we need login key to log in, right? So I'm going to click here. I'm going to click on this one because I already have this key on my local machine. Now, if you don't have a key pair, please make sure you create the new key pair here. Click on create new key pair and create that key pair. Immediately you create it, it's going to download. It's going to be downloaded into your machine, right? You need that key to log in. Then also, I'm going to scroll down to the network settings, right? Click on edit, and I'm going to select the VPC, the one I created here. And subnet, I'm going to put it on a public subnet, right? I'm going to put it on this one here. Click on it. Then after that, assign public IP, enable. We need public IP. Then after that, secure. I'm going to select existing security groups, and I'm going to select the control plane security group. Now you can see the control plane security group, the one we created, not quite long. So I'm going to click on that one. Then I think that's all we need for the security group, and we need just one master node. Let's click on launch instance. Now, while we are launching this instance, let's just create the other 2 worker node, right? Click on launch instance. Let's call them worker, right? Let's call it worker. Then click on Ubuntu server, and also let's select T2 medium as well for the worker node. And this key pair, I'm going to select my key pair as well. And also for the network, I'm going to select my VPC. And also for the subnet, I'm going to put it on the public subnet as well. I'm going to put it on this public subnet or any of that one. So just put it, make sure that it's running on the public subnet. Then assign public IP, enable it, and security group, select existing security group. Then I'm going to look for the worker node security group, the one we also created. I think that's all we need, and I'm going to make it 2 because we need 2 EC2 instance for the worker. I'm going to click on launch instance. Now let's go back. Now if you click on your instance, you're going to see the 3 servers that we're going to be using for this demo. Now for simplicity, to make it easier, let's call this one worker 1 and let's call this one worker 2. Cool. Now the first thing we need to do is to connect to the master node to set things up. Now I'm going to grab the public IP from here and I'm going to head over to my terminal. Right? So I'm here on my terminal. So the first thing I need to do is I need to connect to the machine. Now, whenever you download a key pair, by default, it goes to your downloads folder. So I'm going to go to my downloads folder. I'm going to go to downloads like this. Then also I'm going to connect to, I'm going to connect. So I'm going to use SSH-I followed by the name of my key pair. I call it evote.pem, and also I'm going to connect using the name of the username that comes with the machine like this, and I'm going to hit enter. Now it's going to ask you a question. I'm going to say yes, and it's going to log you in. Now, if you are surprised how I was able to connect, let me just show you. So if you come here and you click on connect, you're going to see the command from here. So if you come to the connect, go to SSH client, you're going to see that the command that you need to connect. Can you see the command here? This is exactly the command that I copied. Now, the reason why you cannot see the IP, the reason why you don't see the IP here is because you can also use the DNS name of the server to connect, which is this one. This is the DNS name. You can use the DNS name, or you can use the IP address as well. In my case, I used the public IP. Now let's go back. Once we are connected to the machine, now the first thing I want us to do is to change the host name, right? We don't need this random IP, this thing here. It doesn't make any sense. So how do we change that? So we need to use, we need to change it using sudo host name ctl set host name. I'm going to call this one the master. I'm going to hit enter, and it's not going to take effect right now until you exit from the server and then reconnect. Now, if you connect, you're going to see that the name has been updated. Now, you can now see the name here, master. So after that, let's update our machine. I'm going to use sudo apt update like this and hit enter. Now, we've connected to the machine. Now, let's install the Kubernetes component. Now, let's go back. Now, if you come here to the installation, you're going to see how we can install everything within the cluster, right? So let's scroll down and understand the different requirements. So all the ports are be open, right? We've opened all those ports. Now, the next thing that we need to do is to disable swap. Now, swap configuration, right? We need to disable this. Now, if you don't disable swap, your setup is not going to work. Now, let's copy the command here. So to disable swap, you can read it from here. We need to add this sudo swap of -al. Now, let's go back to the server and put that here. Yeah, that's going to disable swap. So once swap is disabled, we need to install a container runtime. Mind you, we need to install this before installing kubelet and kubeadm, or you can even install those components and then installing your container runtime as the last thing. Now, what container runtime are we going to be using? We're going to be using containerd as the container runtime. Now, in the same documentation, if you scroll down to the installing container runtime, you're going to see container runtimes here. Then click on it. Now, once you click on the container runtime, right, scroll down to the bottom, you're going to see containerd, CRO, Docker engine. Now, all these are the container runtime that you can use using kubeadm. Now, right, we also need to configure some network settings, right? We need to enable IPv4 packet forwarding. So let's copy everything here like this, copy it and go back to the server and, paste that and hit enter. Now, once you hit enter, you're going to see all of these being displayed on your screen. Now, go back again and, just to make it permanent or to check if it has worked, copy the last command again, go back to your, terminal and hit enter. I think everything looks good. Now, once that is done, we can now go back to install the container runtime. Now, click on containerd, which is the one we're going to be using. You're going to see everything here, and you're going to see how we can install it. Now, how do you install containerd, right? Because containerd is a container runtime. Now, if you come here to the instruction, you can see to install containerd on your system, follow the instruction getting started with containerd. So we're going to click on that. Now, once you click on that, you're going to scroll down to the different method of installing containerd, and this is the first option. We don't want to do that. The second option is using systemd. We don't want to do that, and we're going to be using the second option, which is using our apt repository, which is using like sudo apt install, those kind of thing, right? So which of the operating system are we currently using? So we are using Ubuntu. So we're going to be using Ubuntu, right? Click on Ubuntu and then scroll down to the installation. Now, how do you install it? Now, these are the installation guide. We have prerequisite, and OS requirements. We don't need all of that. So just scroll down to the bottom. You're going to see installation method. You can see install it using apt repository. Now, this is exactly what we need. So these are all the commands that we're going to use, but I'm not going to copy them one after the other. That's going to cost us a lot of time. So I'm just going to copy everything, go back to the server, and I'm going to, run it as a share, as a script. So I'm going to go install.sh. I'm going to, paste everything there. Then after that, save it. Then after that, we also need to run the last command. This is not just the command that we need to run. We also need to run the sudo apt install. And because we only need containerd, right? We don't need Docker CLI, containerd. We just need to run sudo apt install containerd.io. Now, sudo apt install containerd. Oh yeah, so we need to run the shell script, right? This shell script that we need to run this. Otherwise, this is not going to work because this is going to update the package repository. So how do we make this executable? First, we need to make this executable, because if I run it like that, install.sh, you're going to throw me permission denied, right? So I'm going to make it executable. I'm going to run sudo chmod 700 install.sh, and I'm going to run that command again, and this should work. So let's wait for some few seconds rather, and to see. So everything looks good. Then after that, we now need to run the install containerd.io. Now let's wait to install that. Now, okay, that was fast. So we don't need to go back. So what do we need to do now? Let's confirm that our containerd has been installed. So let's run sudo system ctl status containerd and hit enter. As you can see, containerd is up and running. It's running smoothly. Now, what next do we need to do? We need to install the kubeadm and the rest, kubeadm and kubelet, right? So let's go back to, let's scroll down to how we can now install kubeadm and the kubelet. So if you scroll down, you're going to see, we just did the installation for the swap, and also we've installed the container runtime. And now the next thing that we need to do is to now install kubeadm, kubelet, and kubectl. Now scroll down to the bottom. This is how we can install it. So we need to update the package repository, and we need to download the key, the GPG key to sign to confirm that we are downloading it from a trusted repository, right? So let's take it one after the other. So let's copy this entire command here like this. Click on copy, go back to the server, EC2 instance, and paste it, hit enter. Now, why is that is installing, go back again, copy this command, the last one here. You can as well copy everything, it doesn't matter. Go back and paste it here again. Now that has been, that worked. So let's go back again. And the last thing that we need to do is this one here. So just copy everything from here and go back to there and then hit enter. Now we've installed the package repository, right? Now, how do we know which specific version of Kubernetes that we want to install? Now, by default, the version of Kubernetes that you want to install is the same with the kubeadm version and the kubelet version. So if you are installing kubeadm of 1.34, it means you are also installing a Kubernetes cluster of 1.34. So how do you know which version that are current? We're going to be running the sudo apt cache medicine kubeadm. I'm going to hit enter. Now, once we do that, we're going to see the versions that are available from this repository. And I also need you to understand that the reason why we have 3.4 there is because by default here, the documentation is currently using the latest one here. So for instance, if you don't want to use, you can see that these instructions are for Kubernetes version 1.34. Now, if you need a much more, lower version of Kubernetes, I will advise you to come over here, click on version, and select the particular version that you want to install. But being that this is the latest version, it comes with the, it comes with 1.34, which is the latest one here. So hence, you can see that we have 1.34 here. Now, this dash 1.1 does not actually matter, but the major thing is whatever you can see here. Now, we've done that. Now, let's now install kubeadm, right? Now, this doesn't mean that kubeadm has been installed. Now, this is just the available version of kubeadm that we have on our package repository where we can download softwares and packages. Now, these are the ones that are available there. Now, once we've done that, we now need to now install the kubeadm itself, and this is the command for us to install it. So I'm going to copy it, go back again, I'm going to paste it. The next thing that we need to do is to specify the version, right? So I'm going to turn here to equal to, I'm going to copy the version that are available, which is the one that we want to install. Make it equal to, do the same for this one, and also same for kubectl here like this. I'm going to hit enter. So as you can see, everything has been downloaded. So that's good. So we've installed all the components that we needed in the cluster, right? And then you need to understand that kubeadm is a tool, kubectl is a command line tool, but kubelet is a service that is running, that is running on the server. Now let's see how kubelet look like. So if we run sudo, let's clear the screen. If we run sudo system ctl status followed by kubelet, we're going to see that kubelet has been installed, but it is not running at all. As you can see, this is the Kubernetes node agent. Now kubelet has been installed, but it's not running yet. Now the reason why it's not running yet, you're going to find out in a second. So everything has been done, but we need one little step. We need one more thing to do. Now, what is that thing that we need to do? Now, like I said, now, if we go back to the container runtime, right? Let's scroll down to the container runtime. Click on the container runtime and then click on containerd. Now, if you scroll down, they've told us that with the container runtime using containerd, we need to specify a specific configuration inside the containerd config.toml file. We need to change the system DC group to be true. Now, this is because by default, kubelet uses system DC group to enforce resource limit and request. And the one that comes with containerd is the one that uses cgroup-fs. Right? Come back to your server and paste this command here like this. I'm going to leave it there for you. So basically, we are running sudo containerd config default, which means that we are trying to generate a default configuration, and then we are sending it directly to the default location where containerd configuration file are being stored. So we're going to hit enter. Now, once we've hit enter, right, we need to, change that setting here. If you scroll down, this is what we want to change here. We want to change it to true. So how do we do that? We need to go to that specific directory, which is this one here, to change that setting to be true. So first of all, let's clear the screen to make it a little bit nice. So let's do sudo vim followed by the name and hit enter. Now I'm going to change that. Going to change it to true, and then after that we will need to restart containerd is running. Now this is where it gets interesting. Now, after this, we now need to install the cluster. We need to bootstrap the cluster. Go back, scroll down. After all this installation, let's go back to the documentation. So after all the installation, you scroll down to the bottom. You can see using kubeadm to create the cluster. Click on it, and this is where we need to create the cluster. Don't worry, I will leave all the guide, all the instructions in the README file for this project, so you can go there and have a look. So scroll down to the bottom. We've already done all of this. We just want to initialize the cluster, the control plane. Now, how do you create the cluster? Now, the initialization also means creating the cluster. Now, this is the command that you need to do. This is the command that you need to initialize the cluster. kubeadm init, right? This is the default command. Now, let's go and state that. Now, this is the default command. Also, there's another specific field that we also need to add, right? Because like I said earlier, when you create a Kubernetes cluster, you're going to assign a pod CIDR block. And because we are running our nodes on a private subnet, sometimes the IP address of those nodes might conflict with the pod CIDR block. So we need to be very strategic, or we need to be very careful with the IP address that we want to specify for the node. So because of that, I'm going to, specify using this CIDR block to make things very fast. So I'm going to, use 10.24.0.0/16. Now, if you look at this IP address, it doesn't conflict VPC IP address. Now, if you come to the VPC, you can see the VPC is running on 10.1.0.16, and by no means it doesn't clash with whatever we have here. So we're going to be using that. And also, we're going to be skipping a special add-on called kube-proxy, because we're going to be using Cilium as our container runtime. So let's hit enter and see if that's going to work. So let's hit enter. We're going to see how everything is being created. Now, this is how to create a Kubernetes cluster. You can see how everything is going. You can see how all the certificates, everything have been generated by the kubeadm tool. You can see that our cluster has been bootstrapped or has been provisioned successfully. You can see the success message. You can see your Kubernetes control plane has been initialized successfully, which is good. And also, for us to be able to interact with the cluster, let's follow this command. Copy that command there and paste it here like this. Now, you can now run kubectl get node command. So, kubectl is a command line tool that helps you to interact with Kubernetes. So, if I do kubectl get nodes like this and hit enter, you're going to see that we have just one node, which is the master node. And as you can see, it is on a not ready state, right? And the reason why it is on a not ready state is because the CNI plugin has not been installed. So we need to install the CNI plugin. So that's all. And now let's move attention to the worker node, right? I'm going to create a new tab here for the worker node, and I'm going to grab the IP address and I'm going to connect to the worker node. So let me go back to the worker node, go to our EC2 instance, go to EC2 instance. Let's start with the first one, grab the public IP and go back. And let's go to the directory where my private key is. And I'm going to run ssh-i evote.pem followed by the name of the user and paste that there, and let's connect. Good. Now, since we have two worker nodes, I'm going to be running this demo. I'm going to be doing this for just one of the nodes, and I'm going to skip it. And then, because if I go through the same thing, if I go through the same procedure for the second one, it's going to cost us a lot of time. So I'm just going to do it for the second one, and I'm going to pause recording and then resume when I'm done installing it on the second node. Now, the first thing that we need to do is to change the host name, right? So we're going to go sudo system, so it's not systemctl, my bad, it's hostnamectl, hostnamectl. So let's exit and re-log in again for us to see that in action. So good. So that has been, that was done successfully. And the first thing that we need to do is, by the documentation, right, we need to disable swap, right? Let's go back again. No, we don't need to go, but let's just go back to the control plane and let's go to the history of the command that we ran. And let's go up. And the first thing we did was we disable swap, right? So let's go back, copy that, come here, and let's disable swap. Then after that, the second thing that we did was we did something like this. So let's copy that as well. Go back to the worker node, do the same thing there. Good. And after that, we run this command, copy that as well. So basically, we are doing the same thing on the worker node as well, but to save time, I don't want to go back to the documentation, the Kubernetes documentation, and start, reading it line by line or word for word. Just going to be copying and pasting over on this one. So after that, we need to install the containerd services, right? The containerd service. So first of all, let's lay hold of the commands to install it. So these are all the Docker commands that we previously used to install the containerd services. So we're going to do the same here. We're going to call it install.sh and we're going to paste everything here. I'm going to save. Then we're going to change it to chmod 700 install.sh. Once we've installed that, let's go back again and we need to run it before running this command here, which is going to install containerd. So let's install. So the installation is complete. So let's install containerd and so while we are doing that, let's head over to the master node again and see what other command that needs to be. Let's see the next command. So after that, we now need to install our package repository, and we need to set up the package repository for installing the kubeadm setup. So let's copy that over here and paste enter. Let's update the package repository. And because I want it to be very fast, right? Let me just go straight. Let me go back to the documentation to copy everything directly from here to make it, make it faster. So I'm just going to copy that. In this case, I'm going to, so that to make it fast, copy that. While that is loading, I'm going back again to copy the last one here. Paste it and go back again, copy the last, copy this one, go back and paste. Don't worry, this looks tedious. I'm going to leave everything in the description box to make it really, really easy for you. So you don't need to start moving tabs, right? One and hit enter. Yeah, okay, cool. So let's wait to get everything installed. So we now have everything installed. Containerd, kubelet, everything is installed here. And the last thing that we need to do is to hold it so that let's hold it so that whenever we upgrade our operating system or upgrade our package repository, it doesn't automatically update those commands. So I'm gonna hold it here like this. Yeah, so good, everything is done. And the last thing that we need to do is the configuration for the containerd, right? This is very important as well. this containerd config file that we need to change the C group to true. So we need to do that, and we need to do that. So after that, let's generate. So remember I told you that this command is going to generate the configuration file and pass it into the default location, which is et/etc/containerd /config.toml file. So let's go into that file and locate the particular field that we need to change. So good. So that has been, that is all good. And we need to restart containerd. After that, we need to restart it. So we need to run sudo d. So containerd has been restarted. So now everything looks good. So if you run kubeadm, you will see that kubeadm is installed. Everything looks good. Now, how do we now add the worker node? So this is the first worker node. We want to add it to the cluster. Now, if you go back to the master node, when we bootstrap the cluster, there's one special command that, when you bootstrap your cluster, you're going to see this kubeadm join command here. And I need you to copy this command even before, bootstrapping your worker node, right? Just copy it and paste it somewhere, because this is the command that you're going to need when you want to join your worker node to the cluster. And also, if by any means you've cleared your screen and you don't have access to this command, don't worry. There's another special command that you can use to regenerate this command, right? So you don't need to worry about that. So copy that, go to the worker node and paste everything here and hit enter. Now we need to run it with a privileged user sudo. So all else is not going to work. So I'm going to add sudo to it, to the command, and then hit enter. Now let's wait. Voila, you can see everything looks good. It said this node has joined the cluster. Now, if you now go back to your worker node and run kubectl get node again, kubectl get nodes like this, you can now see the second cluster worker 1 has been added 25 seconds ago. Now let's do the same for the last node. Like I said before, now I'm not going to show the video of the third one, of installing the component on the third node, just to save time. So I've already added it to the cluster. If you do kubectl get node, you're going to see that the second one, second worker node has been added to the cluster. Now let's check the status of all the pods in the cluster. You do port get all. You're going to see that the core DNS is in a pending state. Now, like I said earlier, without the CNI, nothing is going to work in the cluster, right? There's nothing, absolutely nothing that's going to work in the cluster. But we can see that the core DNS is on a pending state, whereas these other pods are running fine. Now, why is that? Now, there's a concept known as static pods, right? All of these pods, your STD, Kube API server, all of these are regarded as static pods, which means that these pods are not created by any Kubernetes process inside the cluster. They are created from the kubelet itself. So kubelet manages these pods, right? It manages them directly, right? All of these other pods are managed by the Kube API server, but this one here are managed by kubelet. Now, how do you know? How do you know that? Now, whenever you create a Kubernetes cluster, by default, there's a particular location called So if you come to that directory and you run LX, you're going to see you're going to see all the configuration files for the cluster, right? You're going to see admin.conf, you're going to see superadmin.conf, right? Don't worry about that. And also, we also have manifest, right? If you come to this manifest, if you go to the manifest folder, now this is where you see all the pods that are created. Now, any manifest file here that you can see here is a static pod. Now, you can see that we have 1, 2, 3, 4, and those are these 4 components that you can see here. Now, for the etcd is created. The etcd pod is created from this etcd.yaml file. The kube API server itself is created by this. So what that means is that if you paste any Kubernetes manifest file on this directory, that means that particular pod becomes a what? It becomes a static pod. And as you can see, that's the reason why they are in a running state. But if you deploy any application now, it's also going to be in a pending state. Now, let's try something. So let's deploy a simple Nginx application, right? Let's run kubectl run. Let's call it Nginx as the name, and also the image name to be Nginx. Now, if you do case get pod, kubectl get pod, kubectl get pod. Now you're going to see that that pod is also in a pending state, right? If you like, check again. It's also going to be in a pending state. Now, what is the solution? That is where the CNI now comes in. Now, for the CNI, we're going to be using Cilium as our CNI. So if you go to Cilium, search for Cilium, you're going to see the quick installation. Now, let's install Cilium. Let's install Cilium in the cluster. Now, how do you install Cilium? You can see here, install the Cilium CLI. You need to install the CLI first. I'm going to copy everything from here, go back to the master node, and then paste it here. That's going to install Cilium here. Now, how you interact with the Cilium, platform itself. So you scroll down. Once that is installed, now this is the final command that you need to run to install everything inside the Cilium. Now paste it here. So this is the command that you need to run to install the Cilium fully in the cluster. And when you run the Cilium install, by default, it's going to use the kubectl command to apply to the cluster. And also, this under the hood uses a Helm chart as well. But before we do this, I want us to change some few details. Because obviously we don't have kube-proxy, so we need to specify an argument that we enable Cilium to also run as a kube-proxy and also as the CNI plugin of the cluster. Now, another set of feed here. Let's add set, and we want to use it as a kube-proxy replacement. And also we're going to set that to true, and let's hit enter. As you can see, this is the message we are getting. Cilium will fully replace all functionalities of kube-proxy, which is what we want. And also you can see that Cilium has been installed. Now, if you go back and run kubectl get pod again, get pod, you're going to see that your pod is going to turn into a ready state. But before then, let's see what happened. What are the Cilium components that are installed? Now, all of those are installed in the kube system namespace, right? So let's do kubectl get pods in the kube namespace, kube system namespace, and you're going to see all the pods. You're going to see all the Cilium pods that were created, that are getting created. Now, mind you, if you compare this to the previous one we had before, there was nothing running, right? When we run kubectl get all pod, these were only the pods that were available in the cluster as a whole. But now we now have other pods, Cilium Envoy, all of these are running. We have daemon set, and also have pod. Now you can see that the core DNS has now moved from a pending state into a container creating state. Now, if you run again, you're going to see that the pods are running. Now, if you also check the one that we created for the Nginx pod, right, you're going to see that the pod is already in a running state, right? So, guys, this is how you can create a Kubernetes cluster, using kubeadm from the scratch. You can add as many nodes as you want. The procedure is still the same. And yeah, so that's the procedure. If you come to the official documentation, you're gonna see, everything is here. You just need to go through it step by step. And this is what they're going to use in the CKA, the CKS, and the CKAD certification. Now, thank you guys for watching, and find this video useful. Please support the channel by smashing the like button and also leaving your comment in the comment section. If you have any question, leave it in the comment section below. I'm going to answer each and every one of you. I'm going to answer your question. And the link to the repo where all these commands are going to be populated, where all these commands are going to be stored, I will leave that link in the description, in the video description. Thank you guys for sticking around, and I will see you in the next video.